Dear student, good morning to all. Now we are going to the next problem by the Taylor series. Find the Taylor series expansion for the function f of z which is equal to 1 divided by 1 plus z the whole square with the center at z equal to I minus I. That means at the point minus I mean we will take the value z equal to minus I. Okay, va? So in this problem, for what is given the function f of z equal to 1 divided by 1 plus z the whole square, and what is given the point z equal to minus I. Okay, va? Actually, first is what would be the first step? The first step can take generally what would be the first step? The first step you take the given function. In this function we will take the differentiation. Maximum will find the up to third order derivatives. Okay, va? So you take the given function, will find the differentiation. Okay, va? But in this problem, find the differentiation, and after that you can substitute the point. Will go to the next step. Will do the critical. Will be do the next step. Okay, va? So in this type of the problem, suppose denominator will have the order higher order, or suppose for example the f of z value will be given the simple value. For example, log z e power of z, f of z value for example log z e power of z, or sin z or cos z, or mean some simple differentiation. Okay, a simple differentiation means directly will take the differentiation. Okay, but in this problem denominator has the higher order. Okay, so difficult will do the next step. Okay, so in this problem you will take the directly take the nth type of the problem. Okay, I will find the nth type of the problem. We can using the binomial expansion formula, nth term of binomial expansion formula. Okay, suppose you take the given function f of z which is equal to 1 divided by 1 plus z the whole square. Okay, va? F of z which is equal to 1 divided by 1 plus z the whole square. So in this problem differentiation this first time. Before we will take the f of z which is equal to denominator value, will take the numerator value. Before step, first your denominator value take the numerator value. So 1 divided by 1 plus z the whole square can be written as 1 plus z whole power of minus 2. Can I write? Okay, va? So first differentiation this value. First find the f dash of z which is equal to, now to differentiation of right side value, how will be the differentiation this value? Minus 2 into 1 plus z whole power of minus 2 minus 1 become the minus 3. Okay, va? Into again to differentiation inside the value will be get the 1 plus 0 plus 1. Okay, that is finally can write the minus 2 into 1 plus z whole power of minus 3. Okay, this was the first time differentiation. Okay, so in this value can take them, that is minus 2 divided by 1 plus z the whole power of 3. Suppose you want to find the second time differentiation, f double dash of z value. So for the next find the f double dash of z value, you take this value 2 3s are 6, minus into minus become plus 6 into 1 plus z the whole power of minus 4. And third term differentiation, 6 4s are minus 24 into 1 plus z whole power of minus 4 up to the, so in this condition we will write minus 24 divided by 1 plus z the whole power of 5. So maximum will find the third order differentiation. Okay, va? And next what is given the point z equal to minus I. First to substitute the z equal to minus I, f of minus I. So f of minus I mean can substitute this equation 1 minus I whole power of minus 2, that is equal to 1 divided by 1 minus I the whole square. So 1 divided by 1 minus I the whole square, after that by can using the a minus b the whole square formula. So can using this formula. Okay, so the difficulty can this value will do the difficult this step. Okay, and next up, so suppose you will find the f dash of minus I means can substitute this here, minus 2 divided by 1 minus I the whole power of 3. So that is 1 minus I the whole power of 3. So difficulty will do the next step. Okay, so if you do the difficult value means you will take the next step, don't to follow this step, and will take the binomial expansion of the nth term steps. Okay, so I'll be explain this problem. Okay. Okay, first step, first you take the, by using the Taylor series formula. So all of you know the Taylor series formula. What's the Taylor series formula? F of z which is equal to f of a plus z minus a divided by 1 factorial into f dash of a plus z minus a the whole square divided by 2 factorial into f double dash of a plus z minus a the whole cube divided by 3 factorial into f triple dash of a plus etc. up to the nth term z minus a the whole power of n divided by n factorial into f r of n of a. Okay, first you take the Taylor series formula. Okay, first step. And next step, substitute at the point, given the point, what is given the point, z equal to minus I. That means a value you can substitute the minus I. Okay, therefore f of z which is equal to, you take that the point, put a equal to minus I. So substitute here, substitute this equation. Therefore the f of z which is equal to f of minus I plus z minus of minus I will become the plus I. Yeah? So that is z plus I divided by 1 factorial into f dash of minus I. Okay, and second third term will write the z minus of minus it will become the plus. Okay, z plus I the whole square divided by 2 factorial into f double dash of minus I plus z plus I the whole cube divided by 3 cube into f triple dash of minus I, and etc. up to z plus I whole power of n divided by n factorial into f power of n into minus I. Okay, so in this equation give the equation number 1. Okay, and next step, here f of z value, what is given the problem, f of z value, you take the f of z equal to 1 divided by 1 plus z the whole square. You take this the f of z value 1 divided by 1 plus z the whole square. So in this value, by using the binomial expansion of the nth term formula, f r of n of z into minus 1 whole power of n into n plus 1 whole n plus 1 factorial divided by 1 plus z the whole power of n plus 2. So why are you using this formula? Because in this given problem, say denominator has the power harder means difficulty will do the differentiation. So that type of the problem can using the expansion formula. That means can using the nth term of the expansion formula. Okay, so I'll take the binomial expansion of nth term formula. This for the nth term formula. Okay, so first step, find the f of minus I value. First we will do the f of minus I value. Okay, first find the f of minus I. We take the f of minus I which is equal to, substitute this equation, f of minus I value is equal to 1 divided by z value, you can substitute the minus I, that is 1 minus I the whole square. Okay, so f of minus I which is equal to 1 divided by z value, you can substitute the minus I, that is denominator value, it can be written as 1 minus I the whole square, that is which is equal to, actually denominator value is based on the a minus b the whole square formula. Okay, so you can using the a minus b the whole square formula. So what's the a minus b the whole square formula? A square plus b square minus 2bb. So 1 minus I the whole square, it can be written as a square, that is 1 square, become 1 plus b square minus I the whole square minus 2ab, that is minus 2I. Okay, that is 1 plus minus I the whole square will become the minus 1. I square value, you know the formula, minus 1. Okay, so that is 1 minus 1 minus 2. Here plus 1 minus 1 cancel, and finally remaining value become minus 2I. So therefore the 1 minus I the whole square become the answer minus 2I. Okay, so in this value, substitute this equation. You take this, what do you have there, 1 divided by 1 minus I the whole square, you can substitute the minus 1, actually minus 2, yeah, that is 1 divided by minus 2I. 1 minus I the whole square value become the answer 2I, minus 2I. Okay, that is actually denominator value is the complex value. So denominator value not become the complex, it is not possible. So you can cancel this complex. If you cancel the denominator value complex values, means that time you can take the conjugate value. So 1 by I can take the conjugate value, multiply divided by I. Okay, so I will multiply divided by I, that is minus I divided by 2 into I into I value, we have the I square. I square value into the formula minus 1. So minus numerator are the minus and denominator are the minus. So minus minus cancel, finally become the answer I divided by 2. Okay, so this is the answer I divided by 2. You take this equation number 2. Okay, and next You take the next find the nth term value. Next find the fr of n of minus I. Okay, you take the binomial formula. So in this value, next find the fr of n of z value equals up to the minus I. Okay, that is equal to minus 1 whole power of n into n plus 1 factorial divided by 1 plus z value what is substitute minus I, that is 1 minus I whole power of n plus 2. That is 1 minus I whole power of n plus 2. We take the equation number 3. And next, the equation number 2 and 3, the equation number 2 and 3, substitute in equation number 1. Okay, you take the equation 2 and 3, substitute in equation number 1. You take the equation number 1, f of z which is equal to, what's the equation number 1, f of z which is equal to f of minus I. F of minus I value, what you got the answer? I divided by 2. Substitute this equation, that is I divided by 2. So, okay, that is I divided by 2 plus, plus here the, you will see there, in this, from equation number 1, here the z plus I divided by 1 factorial, and second term has the z plus I the whole square divided by 2 factorial, and the nth term z plus I the whole power of n divided by n factorial. So in this case I will take the sum of the values. Okay, but that is in this case can write plus summation of n equal to 0 to infinity. Okay, well, you take the summation of is not 0 equal to summation of n equal to 1 to infinity. Z plus I the whole square, next z plus I the whole cube. I will take the nth term z plus I the whole power of n. Okay, well, that is z plus I the whole power of n divided by denominator value as 1 factorial, 2 factorial, 3 factorial, that is nth factorial, n factorial. So, okay, z plus I whole power of n divided by n factorial into, so in this expansion value I will take the sum of the values. Okay, so sum of the values mean that is summation of n equal to 1 to infinity z minus a whole power of n divided by n factorial into f power of n into a, that is f power of n into a. Okay, actually f power of n into a, f power of n into value, what will become the answer? F power of n into minus I value, what do you got the answer? Minus I value. Actually already have to done this value, minus 1 whole power of n into n plus 1 factorial divided by 1 plus z whole power of n plus 2. So in this value substitute here, that is minus 1 whole power of n into n plus 1 factorial divided by 1 minus I whole power of n plus 2. Okay, so in the sum of the values can write the summation of n equal to 1 to infinity z plus I whole power of n divided by n factorial into f power of n into minus I value. Can substitute this value. Okay, so you can substitute this value, minus 1 whole power of n divided by into n plus 1 factorial divided by 1 plus 1 minus I whole power of n plus 2. Okay, substitute this value. And next, that is I divided by 2 into plus summation of n equal to 1 to infinity minus 1 whole power of n will take outside, and n plus 1 factorial also you take outside, and divide by n factorial into the remaining value has a 1 divided by 1 minus I whole power of n plus 2. Okay, so in this value split up this value. Okay, 1 minus I, can you write 1 minus I whole power of n into 1 minus I. Okay, next therefore that is minus I divided by 2, not minus I, plus I divided by 2 plus summation of n equal to 1 to infinity minus 1 whole power of n into n plus 1 factorial divided by n factorial into 1 divided by 1 minus I whole power of n into 1 divided by 1 minus I the whole square. I will try to work on this problem. 1 minus I the whole square value, what will become the answer? Minus 2i. That is this reciprocal value 1 divided by 1 minus I, the already you have to work out 1 divided by 1 minus I the whole square value, what will become the value? I divided by 2. So in this value you can directly can substitute the value 1 divided by 1 minus I whole power of n into 1 divided by 1 minus I the whole square value I divided by 2. I substitute here, that is 1 divided by 1 minus I whole power of n into I divided by 2. Therefore I divided by 2 plus constant value take outside, plus I divided by 2 into summation of n equal to 1 to infinity minus 1 whole power of n into n plus 1 factorial divided by n factorial into 1 divided by 1 minus I the whole power of n. So this is the answer, this problem. Okay.